Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm responding to a question submitted by a calculus student having to do with the intermediate value theorem. And before we get into the theorem itself, I took this polynomial here, which they're giving us x to the fifth minus x squared plus 2x plus 3. I put it into my calculator, which is not cheating. We're going to need our calculator extensively on this problem, just to see where the zero would be, roughly. And I see it's just to the right of -1 when I look at that graph. And in fact, when I asked the calculator to find the zero, it gave me 0.870 repeating. So we're just going to set up an interval around -1 here. And then we'll take a look at what's going on. So let's say, for the sake of conversation, let's say -1.1 and -0.9. Let's use those endpoints. And when I put this into my equation editor, the y equals, and now I'm going into my table feature, and I'm going to find -1.1 on my table, and this is giving me a -2 answer. So all we really need to know is that this is below 0. And when I go to -0.9, it's giving me a negative answer. So that's no good. Actually, I should have known better because that's below 8. So I can't use this interval. I need to find endpoints on an interval around 1 that's going to sort of trap this thing. And I'll show you what I mean in a second, but obviously I have to use a bigger interval here. So -1.2, 0.8. So when I look at my calculator and I look at -1.2, I get a negative value for y. And at -0.8, I'm getting a positive value for y. So what the intermediate value theorem says, well, there must be a point between -1.2 and -0.8, a point inside this interval where the curve goes through 0. So imagine we have a x-axis here. The curve has to go through 0 somewhere inside this interval, because I'm getting to the right, I'm getting a positive, and to the left, I'm getting a negative value of y. So what we do is we take the midpoint and try again. So let me go back to the pencil tool. Okay, so now the midpoint is -1.2 plus -0.8. So that's 2. And the midpoint would be -1. So now I'm going to test in the middle here, -1. And what do I find out? -1 is negative. Therefore, the new interval of interest is going to be from -1 to -0.8. Because to the left, I'm negative, y is negative here. And to the right, y is positive here. And so the curve must go through these two. So now we just have to test the midpoint here, which is going to be 0.9. And when I put 0.9 into my calculator, I get a negative value. So that means the next interval of interest is going to be 0.9 to 0.8. Because at 0.9 it's negative, and to 0.8 it's positive. Well, now we try another midpoint here, which is 0.85. And my calculator tells me negative 0.85 gives me a positive. And so the next interval of interest would be 0.9 to, these are negatives, of course, to negative 0.85. Because here it's negative and here it's positive. So now we take the midpoint of this, which is going to be 8, let's see, 875, right? So now I go back and ask the calculator to tell me when x is negative 0.875, what's the answer? The answer is negative. So now my next interval of interest is negative 875, which is negative, and 0.85. Oops, I wrote that wrong, didn't I? Negative 0.875 and 0.85, where it's positive here, negative here. So once again, you take the midpoint, 0.75 plus 0.85. So this is, let me do that again, sorry. It's 0.8625. And when I find that, you can see that it's positive. So then my next interval of interest would be 0.8625 and 0.875. And you can see we're coming, each time we do this, we're coming closer and closer to what the calculator estimated. Interestingly, the calculator is probably using an algorithm that's very much like the algorithm that we're following. And you just keep doing this until you get an interval of length 0.01, which is not far away from this interval here. Let's see, 0.875 minus 0.8625. Yeah, it's 0.0125. So the length here is 0.0125. And we might have to do this one more time, but you see how we progressed, and you see how I'm using the midpoint each time to cut down the size of the interval that we're considering. And you can see that with each iteration, we're getting closer and closer to what the calculator gave me. Okay, so it's a long process. It's a guess and check kind of process, and it takes a long time. Sorry this took so long, but there's no way around it. So this is the way you make use of the intermediate value theorem to find a zero. So that's it. I'll see you guys next time. Bye-bye.